All right, we're approaching high noon, and I'd like to introduce our next presenter. So, Joe, if you want to turn on your camera, we'll introduce you and get you ready to go. So, our next presentation is from Mr. Joe Toland from USGS and USC, and I've known Joe for, I don't know, probably 20 years almost now as a former student up at Humboldt State when I taught up there. Joe's going to be talking today on a simplified method for rapid estimation of emergency water supply needs after earthquakes. So with that, I'll turn it over to you, Joe, and take it away.
So, hello. Sorry, can you all see the slides here?
No, we're not seeing your share yet.
Not sure. Okay.
There they come. Thank you.
Sorry. So hi, everyone. So first of all, I'm just honored to be part of this group today, and just amazing information, and I've learned a lot already just from Dr. Scorza and from your work. So I did want to take a moment to acknowledge equity as a motivator for my research work in estimating emergency food and water resource needs. My background goes back to working with FEMA. Oh, shoot, this is the wrong presentation. Why does it do that? So sorry. So my background goes back with FEMA, a number of about 16 years. I was actually part of Hurricane Katrina's response, and I was a member of the operations center staff in the actual event. And so I was, probably the least senior person there. But my work, began with working for doing GIS in that event, and my motivation was that there was nothing much I could do as a junior level GIS person. So I was working with their mapping support, and ultimately everything that was involved with the response became the motivation for my sorry about that, the motivation for my my work with modeling eventually in response to earthquake scenarios and supporting emergency food and water. So that's been sort of my background, and I hope you can forgive this momentary lapse here, because the work that I'm doing is very important, and equity has been the motivation from that. And I think we all agree that Hurricane Katrina gave us a important starting point to really start to address resource access issues and questions. And so my area is the most significant to me is the part about emergency food and water needs. And I think those resources are key in many events we've seen time and again. Emergency managers aren't able to understand where the resource needs are, the locations and communities that have resource access issues, and ultimately in a disaster, food and water needs. And so part of my work is to try to work towards solving that problem. And so that's where this work today that you'll see comes in. And I've decided to contextualize it in the broader research that I'm involved with for food and water. We've recently published the paper, and I'll get into some of the methodology there. So
Joe, are we seeing
from there,
the right slide deck? Okay, just want to make sure you're on. There you go. All right. Yeah, now we're seeing the right one.
Okay, I'm so sorry. Yeah, I
had the wrong slide deck open. Okay, and it's not in presentation mode.
Go ahead and do that. Yeah, I'm on a So I'm gonna just have to scroll through here because oh, there we go. Let me see the slideshow. Can you all see that?
We're seeing presenter view. You might want to swap screens. There you go. Maybe.
In our paper, we developed an innovative. I don't know why that's coming up there. I thought I removed all that. So will this work? Because this,
yeah,
I think,
go ahead and just scroll through that.
Yeah,
way. That's fine.
My apologies again, but like I said, the research is really important, and the media is only part of it. But in moving forward, the motivation is our earthquake threats in Los Angeles are extensive, and food insecurity is a very important part of understanding community need in a disaster. And most of the work that has been done so far is on looking at from resource requirements from the demand side perspective or from the supply side perspective. So looking at what communities might have a disparate resource requirements and disproportionate risk. These are all parts of the modeling work that I'm involved with. And so part of that comes from all the way up from the federal to state government planning tools, is that there is no standardized modeling methodology for this resource needs estimation. A lot of the work is general. We can understand things at a broader geographic level, but identifying the location of households and the ability to target resources to communities that might have a historic need or have a vulnerability with social vulnerability gaps and food insecurity are all part of that work. So in the estimation of the water, I've been involved with the Hayward earthquake scenario, and we have basically been able to target resources down to about a 250-meter grid using the latest tools from operations research engineering and the scenario-based studies. We've been able to contribute rapid assessment tools to help prioritize the resources to impacted communities, as well as providing detailed information on where the vulnerable communities may be, so that emergency managers can identify early on, just from a modeled tool, without any baseline data from the actual event, the kind of issues that might come up, and help to keep that in the awareness of the decision makers. So, from my experiences in Katrina, where there was nothing I could do, this has been my, motivation. I thought, how can we model and understand community need? And so, this is the work that's come out with working at USC and getting my master's degree there, as well as working with the USGS now as a researcher. This has been our research goal for the Bay Area, and also to apply it in Los Angeles. So the modeling work, and I'll scroll through some of these slides rather quickly, just because there's some important end results, I think, from the equity side in working on this modeling that I'd like to show and showcase. But in general, we work with utility and transportation disruption as sort of the core part of understanding where food and water resource needs might be, because those all relate to business interruption. They relate to transportation disruption, utility disruption, are all part of that problem space. But there's another factor, and that is, equitable resource access, food insecurity, the social vulnerability areas of disproportionate socioeconomic status disparities. All these parts will push that number of need into a greater or lesser tier of requirements. And so we want to be sure that when the county and the community organizations are preparing for resource dispersions and disasters, that they understand that there's two parts to it. There's both a community and vulnerability side and a physical vulnerability side that's dependent upon the event. So in our framework, and then this is the general framework, I work with hazards and utility disruption, and I have in the research developed an algorithm to push that information using some distribution that is based upon social vulnerability indexes, as well as food insecurity measures from the USDA, that can then give us a hotspots of where we might be interested in community activity. After 3 days, food and water access is limited because businesses, are interrupted. Their refrigeration and other pieces of their supply chain are all disrupted, and so there's only about 3 days worth of food at local businesses. And that also goes for something like a food bank and community organizations that provide a large portion of the community food on a regular basis. So all those households will immediately fall into food insecurity. And that's where the importance of understanding where the vulnerability and risk are in relation to that disaster. So in Los Angeles, the 7.8 San Andreas earthquake scenario is the core of our modeling base input and we use work from the Shakeout scenario, which is one of the earlier but very sophisticated models of what a large-scale earthquake in the county and in the region would look like. And so you'll see here several data sets from that. I also have some work in the Bay Area. So I'm just showing this so you can see that it crosses boundaries and jurisdictions and borders. We're trying to work on developing a national method for resource estimation with FEMA and HAZUS so that this never becomes a problem in that space within that early stages where there's no tools to help decision makers again. The utility and transportation disruption component all relates back to core indicators like power, water, damage to the transportation, things that we have lots of science and engineering behind that allows us to provide a spatial representation of risk and vulnerability. So, part of my work in research has been learning about all these different fields and how they all connect, how those relate to businesses and how that relates to food insecurity. And ultimately the two faces of food insecurity becomes a social as well as a engineering intersection. And it's that intersection that I think we're starting to see a lot more interest in research. How do these components affect social and societal consequences? And that's where my interests lie. Moving into further physical vulnerability questions. In the model, I have then generated risk surfaces and been able to, within the methodology, build a physical vulnerability estimate. So when you have an earthquake, what percentage of the population would have an impact from utility and transportation disruption? And we can associate that with the percentage of resource needs. So one household, if there's 50% of the population would have a disruption and that would affect food access, water, power, then we were able to estimate that, we might need to push more resources into those areas than a less percentage. It's fairly straightforward. In the water component, so in my paper we recently published with the USGS, it focuses on that one piece. And that's where you can start to see the real power and expressive power of using these tools to identify communities in need. Because when we can use tools like bathymetric mapping, using the American Community Survey indicators, and then generating estimates of the populations that would have impacts, we can target and identify where those resource areas might be prioritized for action by the federal or state or local government. So this is the methodology from the estimation of emergency water in the Bay Area. It's just as applicable in Los Angeles, but this is our paper that we recently published. And so you can see in the Hayward fault scenario, there's a disproportionate amount of potential impacts in the lowland areas, as well as a large area in South Bay and San Francisco. So currently, social vulnerability, there's a predominant interest in index-based models, but this doesn't really represent outcomes at the household level. And I think from what we've heard today, it's important to know that there's differences in different households and how they respond and how they, the different opportunities and different relationships they might have to resources and being able to succeed. And so social vulnerability, while from Hurricane Katrina onward, this has been an important research goal, we've ended up going into a more granular level of modeling. And so this is the first step, I think, in understanding disparity and making sure to include that in a modeling approach for emergency resource access. And so in my algorithm, basically, I've taken those indexes and normalized them and then use that to weigh our estimate of physical vulnerability. So this is from my master's degree thesis and work that I'm currently involved with in building a conceptual framework on emergency food and water resource needs modeling. But we get something here, which I think is the most interesting result. If you see, say, our standard deviation or our value here at 0, that would be with only looking at physical vulnerability, the differences we might see, not considering any social factors or any risk disparity, anything that might be involved with food insecurity, food access, any of those factors, for equity and disaster response. The first one would just be related to the physical side. And so when we start to use the vulnerability modeling, we can then start to see that we can push more resources into areas that would have disproportionate need. And the part of that, the last slide here shows a 25% increase at one standard deviation of the number of indexes, quartile of the social vulnerability index number of them. But it basically allows us at every one of those 90 meter or 1 kilometer grid cell to estimate the weighing effect. And so you'll see in the Los Angeles version, I've been able to integrate all that and using a 1 kilometer grid here, estimate the household level from the dosimetric mapping where the emergency needs would be greatest. And so we're using this population base from Landscan, which is an ambient population model, and then applying that with our community vulnerability to see the results here. This is the San Francisco version, but in Los Angeles, the results for emergency food and water needs are shown here. And the summaries in Los Angeles County showing that we have over 3 to 4 million households, that are 300,000 to 400,000 households, and the hotspots then allow us to start to prioritize where resource needs might be localized. And so developing the model with this 90 meter grid, we have a community level estimate of where risk and vulnerability might occur for food access and food need, emergency food need in day 3 of the disaster. And so, this is, I think, is really this was the end result for my master's thesis and sort of the beginning for my research work with emergency water, refining the details and then going back in, my next steps are to go back and to refine the modeling further and use various tools. We were able to publish this recently in the journal Water. It was part of the Hayward fault earthquake scenario, and ultimately a core tool in the hands of emergency managers and decision makers early on to start to see where and what communities need might be. And the future applications, looking at long-term requirements, how resource needs decrease over time. There's a lot of work done now with AI and with machine learning tools, regression, ARIMA, that can look at where you are using a Bayesian approach and estimate where you'll be. And so these all assume you have data. So in a disaster, we don't generally have information early on. So that's where modeling becomes really important.
3 minutes.
But in this case here, yes, thank you, Steve. And in this case here, you can see we have a vision of like where the community need might be the longest versus where it was most severe in the early days. And so these kind of tools are all important to understand where resource access and issues might be long-term, because we all have food deserts potentially in areas where there's been severe impacts, where there's been severe loss of infrastructure or damage to buildings. And some of these areas might be candidates for investment. Now, those are the kind of questions that GIS tools and modeling can help answer. So this is again showing from that what may be a distribution point. So a community might be able to access food and water from one point, within walking or driving distance close by, and how they might be supporting the community long term. This can be a shelter site, anything as far as even a Target or Walmart or other private sector entity. So my future work is towards building that localized, that individual level modeling of communities in need, and that's where equity for me, I think, is most visible and where I can contribute the most, because we can really build a community level estimate of food, emergency food and water resource needs, but using tools like the American Community Survey, maximum entropy modeling, dosimetric mapping, and ultimately expanding and integrating this with multiple hazards, and also with the federal and state policy and local policy on food insecurity and food access. And so I'm sorry again for the media blips, but I hope you understand, you see the importance and my passion in the work, and that we get to help solve these problems together somehow in the future. Thanks a lot.
Okay. Well, thank you, Joe. We have some questions both in the Q&A and other channels I get. So just start with the first one in Q&A. What are the libraries or programming tools you're using to do your disymmetric modeling?
Awesome question. So I work, and I have worked, originally it was MATLAB that I used and utilized the Esri tools, ArcGIS, and spatial analysis and analyst connecting data across, analog methods. Now I'm using Python, and I'm using R and RStudio and the R bridge. And so I'm going to probably migrate everything into Python as we move towards more modular architecture for working with the FEMA people and HAZIS, and working with other components of the risk assessment, risk modeling tools that are part of the toolkit for emergency managers. So that's sort of the direction I'm going in. The disymmetric mapping comes from Oak Ridge National Labs, at least that part of it. The Landscan model is, there's a lot of information online, and it is publicly accessible. And it's a great tool for visualizing local level, population issues.
Okay, and then kind of a related question. Could you briefly elaborate on how you did the downsampling of LA County to the 90-meter resolution from the 1 kilometer or other resolutions you had?
That is also another great question. We all, as GIS people, I think, are familiar with the cross-level inference problem and problems with edge effects and, I think they call it the modified aerial unit problem. And when disymmetric mapping is thought of, prescribed for, solving a data type problem, that's always, in the mind of the analysts of the kind of data, whether they're using data that is an aggregate and will have like a, that kind of ecological fallacy when you start to make inferences at the local level. So as I said, the information is valid at the census block and block group levels, from the census demography. But the Landscan model is able to show that there's a very close correlation to their summary results of counts of populations with that geography. But there's more complicated issues going on when you have aggregates, and the aggregates are usually the kind of information that we want, like median household income or percent poverty, below poverty. And so my approach to that is going to actually hopefully involve some future research, in my PhD, and applying some population synthesis modeling approaches using micro samples and micro simulation. And I think that method, within the confidence intervals of the sampling methods from the census, is the way to approach, that issue.
Okay, and then I have one more question that came in. Did the data that you used in these modeling exercises all come from public sources, or did you have other types of data involved?
Another good question. When I first started out, Landscan was a specialized data set for emergency managers, and I had to get permissions and get a sponsor of the federal government, because I had left after that point, that were able to support me. And now it is actually all publicly accessible. So most of the science behind the modeling comes from tools like the HAZIS technical manual that publishes a lot of the distribution functions on these risk and vulnerability curves, as well as recent studies, the Shakeout scenario and the Hayward scenario, which is actually the most advanced earthquake scenario ever developed. So the multidisciplinary nature of getting everyone together to solve these complex problems has fostered a lot of good science that can translate into spatial and data related domains. And so everything at this point is public, and everything I've published is public, including my thesis, in that I want the way to move the research forward is to have open access. So I'm totally a supporter of open access research and coding.
Okay, well, very good. We are at about 5 of the bottom of the hour, so I'd like to thank Joe again. It's important work to be planning ahead for these big events, though we hope we never need the data. It's better to have it in advance so we can plan appropriately. So thank you again, Joe. I will mention, I put in chat, Joe has a poster in the map gallery that details some of this as well. The links that he's got there, I believe some of those are also on his speaker profile if you want to follow up. So with that, we'll take 5 minutes and return at the bottom of the hour for our next speaker, Austin. So take 5 and we'll see you at 12:30.